integrating f of ax plus b. So the general idea here is it's a more complicated integration. Essentially, what we're going to do is reverse chain rule. Now, there's a very important thing I'm going to point out at the very top. This reverse chain rule is only when the inside is linear. If it's nonlinear, it's a whole different ballgame, and we're going to do that in the next video. For now, we're only focus on reverse chain rule when the inside is linear. So if you remember the chain rule, right, let's talk about that, right? So let's say I have my function here. The chain rule, the derivative would be take the derivative of the outside, so f prime of x. Leave the inside alone. Then you times by derivative of the inside. In this case, that'd be a. Right? So you take the derivative of the outside, leave the inside alone, times by derivative of the inside. Now, the same thing happens with the integration, right? So let's say it's my function, and I want to integrate it. Now we're going to treat that like that's the derivative, right? That's f prime, right? That's why it's lowercase. So just like in chain rule, what we do is we integrate the outside. So it's going to go to the capital, leave the inside alone. And now here's the difference, right? Normally you multiply by derivative of the inside, and this time we integrate it. So instead of multiplying, we're trying to go backwards. The opposite of multiplying is you divide by the derivative of the inside or multiply by the reciprocal. So that's the idea. So reverse chain rule is you integrate the outside, leave the inside alone, and then divide by the derivative inside, right? It's the opposite. We're doing the opposite of the derivative. Divide by the derivative of the inside. Or u prime, right? There we go. So that's the idea. And that's pretty much it. Let's do some examples. Let's start with e, because E is easy, right? The integral of e is just e. Right, a little review. Right, the derivative of e is just e. So how are we going to do if there's a power up there, if it's a chain rule type of thing? Well, just like I said, right? We take the integral of the outside, integral of e is just e, leave the inside alone, and then you divide by the derivative of the inside. And then don't forget the plus c. So that's going to be the whole idea, right? It's reverse chain rule, integrating to reverse chain rule. So I see this, e, I'm just so we're just have the same idea with e, right? Just copy it. It's an e. And then times by divide by derivative of the inside. So derivative of the inside here will be -3, so times -1/3 plus c. So that's how we want to do our e's, right? So let's say we integrate e to the u dx. It's going to be just copy it, and then times 1/u prime, right? Reverse chain rule. So let's use that here, right? These are easy. You're just going to copy it, and then divide by the derivative of the inside. Derivative of the inside will be -1, so 1/-1 plus c. Or if you want to be nicer about it, negative e to negative x plus c. Right? That's just a simple idea. Let's do it one more time. Add one up, because this is fun. And again, notice it only works when it's linear. If I put that squared, I can't do it. And we'll talk about that more in the next video. Right? So if I was doing this one, I'm like, okay, I'm going to copy it. And then I'm going to divide by derivative of the inside plus c. That's all it is, right? It's like a reverse chain rule. Now we can do the same thing with power, right? We can do the same thing with the power rule. Notice here, right? There's a power rule to the nth power. So we'll take the derivative of the outside, add 1 to the power, divide by a new power, and then we're going to divide by derivative of the inside, or multiply by the reciprocal, right? Same concept. So this one right here, I'm going to go, okay, I'm going to integrate it, add 1 to the power, divide by a new power. So I'm going to get 1 to -1 minus 3x, the fourth, over 4, times the derivative, divide by derivative of the inside. I keep on saying that. So this case will be -1/3 times 1/3. And don't forget the plus c. So if you want to simplify that a little bit, you can. These are both on the bottom. So you get -1 minus 3x to the fourth over 12 plus c. Now the next one here, do you notice it? It's squared. So I can't do it. If I can't do it using the reverse chain rule way, because it's squared. It only works for linear terms. That's going to cause a whole bunch of problems for us. So what's the way we can do this? We can still integrate this. We got to distribute. We do the old-fashioned way. Now wait, remember, this way is always going to work. I actually had to do it on a test once when I forgot how to do the reverse chain rule. It's embarrassing time in my life. So you had to expand this, Mine was to the 7th power, so it took me a while. It's very humiliating. So you do that, x multiplied out, all right, x to the 4th minus x cubed minus x cubed plus x squared. So I'm going to get x to the 4th minus 2x cubed plus x squared. And then we're going to integrate this, because all I did was algebra, right? It just expanded it, because I couldn't do the reverse chain rule because it was non-linear. It wasn't linear. So I had to do all that math. Now I just take normal integration. Add 1 to the power, divide by new power. Add 1 to the power, divide by new power. Add 1 to the power, divide by new power. And you get x to the 5th over 5 minus, that reduces, x to the 4th over 2 plus x cubed over 3 plus c. Don't forget the constant, right? So again, you can still do these. You just have to expand it all the way out, right? But if the inside is linear, then you can do it using reverse chain rule. If it's not linear, we can't do it yet. Something you can never do besides expanding them out. Okay, let's hop on the next type. Next type is a natural log one, right? If you notice that there's something over a bottom here, right? That's always 1 over x, like a natural log problem. So if you see that something inside, that's your inside. So same idea, right? Take the integral of the outside, which is all that mess, so you get the natural log. Leave the inside alone, then divide by derivative of the inside. So let's do this one. Now, first thing I'm going to do, I don't like having the 4 in here because it messes me up. I'm going to pull that out. Remember, it's a constant, you can pull it out. So this is the same thing as 4 integral 1 over 2x minus 1 dx. Now I can do the reverse chain rule. And we're going to integrate this, integrate the outside. So there's a 4 still. Natural log of leave the inside alone. Then times by the reciprocal of the inside, or divide by the derivative of the inside. So bad at saying that. So you get this. You can reduce a little bit. 4 and the 1/2 gets me 2. Natural log of 2x plus 1. All this is in absolute values. Plus c, because that has to be positive. So you get that. Right? A little messy, but that's the idea. And then finally we can do same with sine and cosine. Right? It's the exact same concept, right? It's a little easier to tell that it's like a chain rule type of thing. But that's the general idea. If you take a derivative by doing chain rule, you can integrate by doing reverse chain rule if it's linear on the inside. So like this, like here, right? Oh, there's my outside. So let's integrate this. Integral of the outside, which is negative cosine, because right, the integral of sine is negative cosine. So negative cosine, leave the inside alone, and then divide by the derivative of the inside. So 1 over 3 plus c. If you want to make it a little prettier, that's the idea, right? Reverse chain rule, right? Since we're integrating, we're going backwards. So same concept. You take the derivative, you integrate the outside, leave the inside alone. You still multiply by something. This time you're dividing by the inside, actually, the derivative of the inside. Right? To sum up, we have stuff like this, right? If it's an e, you just want to copy it and divide by the derivative of the inside. If it's a power rule, just do a chain rule, right? Add 1 to power, divide by new power, then divide by derivative of the inside. If it's 1 over something, it's a natural log. And cosine and sine are the basics, right? Don't forget, what's the most common mistake here? A lot of people just forget to do the divide by the derivative of the inside part, just like with chain rule. They like the, add 1 to the power, divide by new power, and they stop there. If there's something on the inside, it's a reverse chain rule. Also, watch out if it's nonlinear. You can't do it if it's nonlinear. We haven't learned how to do it yet. Besides expanding it all the way out, you can't do the rule. So if there's any power higher than 1, you have to wait. You have to expand it the long way. Let's do a few more examples to make sure we got it, and then we can be out of here. So look at this one, right? Straight out reverse chain rule. So I'm going to add 1 to the power, divide by a new power. So I get 2x plus 3 to the 5th over 5. Don't forget to divide by derivative of the inside. So in this case, my derivative is 2, so 1 over 2 plus c. If you want to make it a little prettier, you can multiply the bottoms. Look at this one. That one's ugly, right? You can't leave it like that. We got to rewrite it. Integral of 1 over 1 minus 2x to the 1/2 power. Still got to rewrite that. 1 minus 2x to the negative 1/2 power. Now we're ready to go. Now we can do some integration. Right? So again, normal is chain power rule. Reverse chain power rule. That's a lot to say. We're going to add 1 to the power and divide by new power. So that's 2 over 2. So I'm going to get 1/2. So it's going to be 1 minus 2x to the 1/2. All divided by 1/2. Remember the shortcut brings the 2 to the front. And then you're going to divide by derivative of the inside. Derivative of the inside is negative 2. So let's divide by that. Plus c. I get 2 minus 1, 2x to the 1/2 times 1/2 plus c. And then the 2's cancel. So that little thing right there in the corner is my answer. 1 minus 2x to the 1/2 plus c. Right? But it's the same concept. Just flip it up and then just, oh, it's a chain rule. So since we're doing integration, we do reverse chain rule. Integrate the outside, leave the inside alone, and now we just divide by derivative of the inside. A few more. This one, now see how there's 2 e's here? I'm actually going to do it, I'm going to separate it because I don't like to do reverse chain rule with more than one thing at a time. So I'm going to actually make this into 2 integrals, right? And also I'm going to pull out the 2, just because I can. I like doing math tricks. So minus dx, sorry. You want to put the dx there, they will mark you down if you forget it. Integral of e to negative 3x dx. Right, so this lets me see it a little better. So now I can integrate this one. Oh, it's a little reverse chain rule. Remember with e's it's a little different. All you have to do is copy it. So copy the e to the 2x. And then divide by derivative of the inside. The derivative of the inside is 2, so 1 over 2. I'll leave the plus c to the end. And then I have a minus here. Same thing there, right? It's a little chain rule, reverse chain rule, since we're integrating. And with e's, you always just copy it. And then since we're integrating, you divide by derivative of the inside. So times the derivative of the inside is negative 3, so 1 over negative 3. Now I'll put the plus c for all of it. Simplify a little bit. These cancel. I get 2 negatives, make a positive. I don't know why I said it like that. Plus c. So that's integrate down. Again, to me, it makes it easier if I separate it, so I could focus on it separately. If you just understand the reverse chain rule, it shouldn't be too bad. I think we did this one earlier actually, so I might just skip it, but whatever, it's math. Right? The first thing I'm gonna do is pull out that 4 because I don't like that 4. I think this was a lot easier to see if you don't have the 4 there. And now you can go, oh, it's a natural log because it's 1 over x. So integrate the outside, natural log. Right? Leave the inside alone, and then you divide by derivative of the inside. The derivative of the inside is negative 2, so divide by it. Don't forget the plus c. These reduce. I get negative 2 natural log of 1 minus 2x plus c. One more. So let's do an integration with some sign stuff in it. Same idea. Anytime it's more than 1, I gotta do like both of them. I gotta do like a reverse chain rule. I like to separate it just for my sake. So we're gonna integrate. I'll pull the 2 out. There you go, 2. Know your place. So that plus on this one, integrate cosine 4x plus pi. So we're going to integrate this side first. We're at 2 that stays there. This is a constant, nothing happens to it. Over here, it's a reverse chain rule. Integrate cosine, which is negative cosine. Leave the inside alone. And then times by derivative of the inside. Right, so times by divide by derivative of the inside, sorry. Derivative that's 3, so 1 over 3. Plus, same thing here, right? Integrate the outside, integral cosine is just basic sine. Leave the inside alone. And then divide by derivative of the inside. Now, again, pi is just a number. It looks funky and it's cool, and it's cool looking. But it's just a number, so it goes away. The derivative that's 0. Derivative of this is 4, so we're going to divide by it, 1 over 4. Then we get the plus c. And then we're done. We can make it a little prettier. Negative 2/3 cosine 3x plus 1/4 sine of 4x plus pi plus c. And that's how you do reverse chain rule.